All right, we are going to review the dimensional analysis problems working with grams and moles and conversions. So first of all, I want to review, especially if you were absent this day, what a mole is. So just like we use a dozen to mean 12, a mole means 6.02 times 10 to the 23rd of something. Okay, and a lot of times it's atoms. Because atoms are so small, we need a huge number to represent them. So there were some fun facts on here, like if you had just 1 mole of rice grains, it would cover all the land area on Earth to a depth of 75 meters. Okay, that's crazy. So anyways, when you're talking about atoms, in the past we've been recording the units as AMU. And now we're adding a new layer that says, okay, that average atomic mass on the periodic table also happens to be equal to the mass of 1 mole of that type of atom. So for example, if you've got 1 mole of helium atoms, they weigh 4 grams. In contrast, if you've got 1 mole of carbon atoms, for example, they weigh 12.01 AMU, which is the same as now. If you've got 1 mole of carbon atoms, they weigh 12.01 grams. Iron atoms are a little bit bigger. If you look at their average atomic mass on the periodic table, it's 55.85 AMU. And now we know that means 1 mole of iron atoms weighs 55.85 grams. Calcium, average atomic mass, 40.08. What that means is 1 mole of calcium atoms would weigh 40.08 grams. So what do you notice here? You notice that 1 AMU is equal to the mass of 1 mole in grams. Okay, so let's look down here. Which one weighs more, a mole of neon atoms or a mole of carbon atoms? Well, if you check the periodic table, a mole of neon atoms weighs more. It's like 20 grams versus carbon's 12. So neon atoms must be larger. Okay, then aluminum versus iron. Iron atoms are larger. Copper versus gold. Gold atoms are larger. So an equal amount of each of those, because gold atoms are larger, they'll have more mass. Number 2 is a little trickier to think about. It's saying which sample has more atoms if you have equal masses. So 12 grams of hydrogen atoms or 12 grams of carbon atoms? Well, hydrogen atoms are much smaller. So this sample would contain more atoms because it would take more of those smaller atoms to get up to 12 grams. What about aluminum versus sodium? Sodium atoms are smaller. So you would need more of them to equal the 27 grams. Calcium is smaller than zinc. The smaller the atom, the more there would need to be to make up the same mass as the larger atom. Then we get into molar mass. What if you're not just talking about a mole of a single atom? What if you're talking about a mole of NaCl, for example? You have to add up their atomic masses to figure out how many grams a mole of that molecule would weigh. And sometimes, like Fe2O3, we need 2 times the mass of iron plus 3 times the mass of oxygen to get the grams per mole. The grams 1 mole of Fe2O3 molecules would weigh. All right, so let's do some more practice with molar mass. The first couple aren't anything new. Okay, just a single atom. Sulfur weighs 32.07 grams per mole. Chlorine is 35.45. Then it gets interesting. Water. 2 hydrogens, so we need to do 2 times. Look on your periodic table square. The number that goes with hydrogen is 1.008. Plus 1 oxygen, which is 16. Punch that into your calculator. 1 mole of water molecules weighs 18.016 grams. Baking soda, it's NaHC and then 3 oxygens. So you do 22.99 plus 1.008 plus 12.01 plus 3 times 16. Add that all up and it adds to 84.008. That's the molar mass of baking soda. So 1 mole of those molecules would weigh 84 grams. Sucrose. Let's see, 12 carbons, so 12 times the atomic mass of a carbon, 12.01, plus 22 hydrogens, plus 11 oxygens. Add all of that up and it adds to 342.296. So 1 mole of sugar molecules weighs 342 grams. I'm going to say that in a different way. If you had 6.02 times 10 to the 23rd sugar molecules, they would only weigh 342 grams. That's not very much. All right, let's do some conversions. So this is where we bring in the dimensional analysis. Always start by writing what you know. So here we've got 75 grams of carbon, and we're supposed to get that into moles. Well, make your line underneath, so you've got a top and a bottom, and always write what you've started with, the units, on the bottom, because you want to cancel those out. We're trying to get this into moles of carbon, so write that on the top. Do we know a conversion from moles to grams? Sure, just look at the periodic table square. 1 mole of carbon equals 12.01 grams. Now we multiply everything on the top divided by everything on the bottom, and we get 6.24 moles of carbon. It's a good idea to label your units completely. Okay, then it's the same sort of a problem. 29.9 grams of lithium this time. Same thing. You want to cancel out grams of lithium. You're trying to figure out how many moles of lithium you have. 1 mole of lithium on the periodic table, it says it weighs 6.94 grams. So 29.9, I should have put a line under there, times 1 divided by 6.94, that's 4.31 moles of lithium. And if we think about this for a second, it makes sense. 1 mole of lithium weighs about 7 grams, and you've got almost 30 grams. So it makes sense that you've got more than a mole. How about converting 12 grams of calcium into moles? Same thing, set it up. We want to get rid of grams of calcium and we want to get it into moles of calcium. 1 mole of calcium weighs 40.08 grams. Multiply across the top, divide by the bottom. Answer, 0.3 moles of calcium. Also, if I were being better, I'd be showing that my units are canceling out. Last one, 65 grams of tin. Get this into moles. Looking up tin's molar mass, it's 118.7 grams for every 1 mole of tin. Multiply across the top, divide by the bottom, that's 0.55 moles of tin. So hopefully you're feeling pretty good about converting grams to moles using dimensional analysis. Let's do some moles into grams. So you start by saying, okay, 0.055 moles of lead. So this time we want moles on the bottom, and since it's asking for mass, that really means grams. Check the periodic table. 1 mole of lead weighs 207.2 grams. Multiply across the top, divide by the bottom, 11.4 grams of Pb. Moles of Pb cancels out. Same pattern for 1.45 moles of zinc. Get that into grams. Well, let's get rid of moles of zinc and let's get it into grams of zinc. 1 mole of zinc is 65.39 grams. Multiply across the top, divide by the bottom, 94.82 grams of zinc. This time it's 0.0070 moles of calcium. Same setup. We want to get rid of moles and we want to get it into grams. So 1 mole of calcium is how many grams? 40.08. Multiply across the top, divide by the bottom, 0.28 grams of calcium. One more, 20 moles of silver. Silver's Ag. 1 mole of silver weighs 107.9 grams. Moles are going to cancel out when we multiply. 2,158 grams of silver is how much you've got there. All right, that should really help you out with figuring out your homework. There's also hints about how to do your homework posted on my website, as well as the hand